While we are all joining this event from our own location, we would like to acknowledge that we are meeting on the lands of the Wurundjeri people and the Boon Wurrung people of the Southeast Kulin Nation. We would like to pay our respects to their elders, past, present and emerging, and to all First Nations communities joining us today.
Welcome everybody. Good evening. My name is Adam and I'm going to be your MC for another night at the Observatory live stream. We've got a fantastic evening planned for you tonight. If this is your first time joining us, MBO is a community-based volunteer observatory based in the Dandenong Ranges, sort of out the back of Emerald, and our rustic little hut up there is it's very welcoming, so we always are looking out for new members. If that's something you're interested in, you can jump on our website mbo.org.au. We've got a great night planned for you. Tonight's theme is the summer sky. Tonight we wouldn't be able to do this without the support of our local sponsors, which is the Casey and Cardinia Libraries. If anybody else is interested in supporting MBO, we're always on the lookout for new sponsors, so feel free to reach out to us, info@mborg.au, send us an email. It's a fantastic little organisation. We come from all walks of life, all different backgrounds, and our common theme is being able to share our love of astronomy with all of you. So without further ado, we might introduce the rest of the team. All right, so hi everybody. We've got Petra, who will be looking after our tech tonight. Thanks, Petra. We've got Jamie. Jamie is going to be giving us a little talk on the summer sky and all the different objects and things that you're going to be able to see during the summer period. We've got Merv. Merv, give us a wave. He's going to be telling us some stories and folklore about the Orion constellation and nebula. We've got Drew. Where are you, Drew? Down the bottom there. Give us a wave. Is going to be talking about constellations and asterisms, which I think is their meaning and background. Jackie's just below me. Give us a wave. Hey, Jackie. Jackie's going to be talking about Beetlejuice. We've got Neil. Neil is down the bottom there. Hi, Neil. Fantastic. Okay, he's going to be giving us a bit of a talk about the great nebula in the constellation Orion. Andrew's right in the middle, and he's going to be talking about the Horsehead and Flame nebulas. And then at the end, we've got Stuart down the bottom. He's going to be jumping in and giving a hand on the Q&A. So, without further ado, let's go to the promo video.
Mount Bennett Observatory is a community-run astronomical society in the Dandenong Ranges. We are completely volunteer-run and have over 500 members. We focus on community engagement, outreach, diversity, and helping our members to get the most out of their love of space and astronomy. The observatory was originally built by Monash University for students to do astronomical research, especially on variable stars whose brightness changes over time. Over the next 2 decades, the site was expanded and upgraded, but eventually took a back seat to modern giant internet-connected observatories around the world. In 2011, our 5 founding members reached an agreement with the landowners and took over the lease and established the society. Now, we run over 80 events each year, including members' nights, public viewings, and special events. We have several special interest groups including deep sky observing, radio astronomy, astrophotography, astro arts, and young observers. In 2020, we expanded our online presence and now host regular live streaming events. We welcome all new members and love making new friends with other astronomy lovers. You will be joining a friendly community of passionate, hard-working amateurs who have a grand vision for the future of the observatory. We hope to see you up at MBO soon.
Fantastic. So yeah, it's really important to acknowledge the team that's working with us tonight. There's a lot of people that you will see, but there's a lot of people behind the scenes that you don't see. It really does take a village. So we've got a huge outreach team, and COVID, of course, has changed the world for everybody and the way that we operate as a team. I have recently been getting more involved with these online events, and yeah, it's really important to acknowledge them. So we want to thank all of our amazing volunteers for making these nights possible. And Petra's one of those people that jumped on board sort of the same time as I did. Where are you, Petra? So it's really important to acknowledge all these amazing people, and really important to have your involvement, your participation. If it wasn't for you supporting us, following our streams, getting in the comments and giving us likes and all those other bits and pieces, it really does make a big difference. Don't forget to keep the questions coming in as we go through our talks tonight. End of the night, we'll have a prize, which will be one of our MBO planispheres, which will be awarded to the person with the most interesting question. So yeah, it's really, really important to keep involved. Jump in the comments wherever you're watching. It's really good to see everyone participating and seeing all those interesting questions for the Q&A panel at the end of the night. So let's get into it. Jamie is our first presenter for the evening, and she's going to be giving us a talk about the summer sky. How are you going, Jamie?
I'm great, doing great. Thanks, Adam. How about you?
Yeah, doing well. It's nice to see you back. Haven't seen you for a little while, so yeah, really excited to see. Yeah, really excited to see what you've got for us.
Oh, let's not keep you waiting then. All right, let me pull up my screen. And as Adam said, I'm going to be taking you all on a little bit of a tour of the sky for the summer season. So as you can see here, we've got some lines in the sky. These are the constellations, but at the moment, the sky from MBO, assuming we could all be up there and there was no clouds and all the rest of it, would look something like this. So we've got over towards the west over here, we've got the sun and the moon just there. This program is called Stellarium. It's free to download, so you can search for that one and download it yourself. Though if you do want the phone app, it does cost you a couple of dollars. Very worth it. You can use it on the desktop, on a laptop, or on a phone. And what you can do with this program is quite a lot, including fast forward time. So what I'm going to do is I'm going to fast forward a little bit, and we'll watch the sun go down over on the west side there. And as it gets darker, we start to see the stars coming up. And we have here one of the highlights of the summer sky is the planet Mars. So I'm sure a lot of you would have seen Mars quite a bit, especially during recent times. So we'll give you a quick look at that. So this one is the red planet. So we can see here as well. Where are you going? The planets move quite quickly. Planet actually translates to wandering star, which is how they got their names, because people back in the day didn't know what the planets were, so they just named them wandering stars. And we've got the two moons of Mars here. We've got Phobos is one of them. It's not going to let me zoom in and show you what that one looks like. And Deimos is the second of Mars's moons as well. So we'll zoom back out a little bit and we'll keep going. That's just the first of several planets that we'll be able to see in the summer skies this year. So if we have a look around here, we've got constellation of Orion here. So let me pull these lines back up. Unfortunately, I can't do this on the real sky. It would be a lot easier to find stuff if we could. But if we have a look at this constellation here, this is Orion the Hunter. So a lot of you may recognize the saucepan in here as well. So if I turn off these lines, we've got one star here, draw down to these three going across here, and here's the handle. Now, the handle of Orion is really interesting because what we can do is if we zoom in on this, we start to see different nebula. Now, this one is called the Orion Nebula. I'm not going to go into too much detail about this. Andrew's going to talk a little bit more about this one later. But this one is a really interesting object that you can see in Orion. So if we zoom back out, you'll see that it's in the middle star of the handle of the saucepan in the constellation of Orion. Now, there's another really cool one in the handle of the saucepan here as well. It's called the Horsehead Nebula as well. It doesn't want to play ball with me tonight, but again, that one will be mentioned in a bit more detail a bit later on. Excuse my bird in the background as well, by the way. He likes to talk a bit. So moving on across the sky, we come across to the constellation of Canis Major, or the big dog. And you can see this bright star here. This one's called Sirius. This one's sometimes called the dog star as well. So if we have a look in here, this one is actually one of the brightest stars that you'll be able to see in the summer sky. So normally on a good night, you'll be able to look pretty much straight up and you should see it. It's one of the first ones that comes up after the sun sets. As you can see down here, this one's only about 9:45 at night. So the sun has not long gone down. So this one's quite bright, so you'll be able to see it. If we keep going across, we can see here the Southern Cross. Now, this one is a year-round constellation, but this one can be very useful. Again, not going to go into too much detail because we have quite a bit of information to give you tonight. But this one you can use for various things. You can use it for navigation or just for finding your way around the sky in general as well. So this one, if you can find the Southern Cross, you can find south. And unfortunately, I can't project the cardinal points in red neon on the ground for you. So we've got one more constellation that I want to show you tonight. So we can have a look at the moon here as well, just quickly, just to show you a bit more about what this program can do. So this is what the moon looks like at the moment. So you can see it's a very, very thin sliver just on that side there. You still see a fair bit of detail in it though. Not that we can see that with the naked eye. It just looks like a little bit of light just there. And that one's sitting quite low to the horizon, so it'll be a moonless night. Great if you want to get out there and have a look at some dark sky objects as well, or the Orion Nebula comes up quite well in that one as well. Now, another great feature of Stellarium is that if you can't find what you're looking for, you can just search it up. So I'm going to have a look at the constellation of Taurus, or Taurus the Bull. Now, some of you may know the constellation of Taurus from the zodiac signs. Right, so some of you watching, leave us a comment down below if you are a Taurus as well. Love to see how many of you are out there watching tonight. Now, really cool thing about Taurus is that there's actually something else that we can see in that one. This is called the Pleiades, or the Seven Sisters. There's quite a lot of mythology around this cluster as well. And as you can see in the top left-hand side there, it's called Subaru. And yes, this cluster is where the car brand Subaru gets its name, and also the logo as well. Now, a lot of people can see 7 stars. Some people can only see 6. If you can see 6 to 7 stars, your eyesight is generally pretty good. That's just naked eye. If you've got a pair of binoculars or a telescope, you can see a lot more than that. So just have a look for Taurus the Bull. There's a bright red star there as well, nice and close to Betelgeuse. And so if you can find those, generally speaking, you'll be able to find the Pleiades there as well. But that's not all for the summer sky. We've got quite a bit to go. So what I'm going to do is I'm going to just quickly zip around a little bit and show you some other planets that we'll be able to see. Now, this one's not quite up yet. So let me just advance the time a bit. Quite a bit. There we go. And if you have a look just at sunrise, we can see the planet Venus. Now, Venus goes by a couple of different names. We've got the morning star or the evening star. Now, at the moment, it would be going by the name of the morning star. You can see all the atmospheric clouds on the planet there as well. Now, these guys tend to move around a bit as well, and I'll show you a little bit later on as well how much they're going to move around throughout the coming weeks and months. As I said, planets are called wandering stars, and for good reason. Now, what we're going to do is we're going to have a look. We've seen Mars, and we're going to have a look at where Mercury is hanging out, because Mercury is another one that we're going to be able to see during the summer. So just, oh, that's the wrong way. So you can reverse the time in Stellarium as well, which is pretty cool. So it means if you wanted to, you could have a look on Stellarium and see what the sky looked like the day you were born, which is pretty cool. You can see it goes around a little bit. Now, Mercury is hanging around the sun there as well, so we won't be able to see that one naked eye. Please don't try and look at it with a telescope or binoculars, because if you accidentally get the sun, you will damage your eyes and you could possibly go blind, which is not what we want, because then how would we see the stars? So you can see here, just use a program like Stellarium to have a look at Mercury in the meantime, but you can have a look and see that it runs away from me a lot. Oh no, come back. Oh dear, that doesn't want to cooperate with me. There we go. So you can see it looks a little bit like the moon there as well. It's a lot hotter than the moon though. It is the closest planet to our sun in the solar system. So we'll zoom back out, and a few more planets to go as well. Oh, if we zoom back in a little bit more, we see the king of the planets, Jupiter. Now, for those that don't know, Jupiter is the biggest planet in the solar system. It's a gas giant, and you can see different gases there making the beautiful colored bands that we know and love. And the four main moons of Jupiter there as well, the Galilean moons. We'll zoom back out. Got one more planet to go, and then we'll start getting into the nitty-gritty of how they're going to move around a little bit. Now, this one is a lot of people's favorites, and nice and close to Mercury and Jupiter is Saturn. So you can see the beautiful rings of Saturn there as well. We can get this kind of detail in a telescope as well, not necessarily in binoculars unless you have a very, very, very powerful pair of them. But in a good telescope, you'll be able to see what's called the Cassini division, as you can see just there. All right, so what we're going to do is I'm going to show you some upcoming events for the summer, and then I'll hand over to our next presenter. So just going to advance the time. The first up is on the 21st of January. Just going to slow that down just a little bit, seeing as we're starting to get nice and close. Now, this one, you will need a telescope to be able to see this one, because the planet Uranus, or Uranos, as the Greeks pronounced it, is going to be nice and close between Mars and the waxing moon. So we're hanging out on Saturn now, so I'm just going to slow the time down to normal speed there now, and we're going to search up that one. Oh. With me, my computer is not cooperating very well with me tonight. So we're all the way over here, and so we can have a look. I'll show you this one really quickly so we can see the beautiful blue and the rings around it as well. This one, you need a very, very powerful telescope to have a look, and even more so if you wanted to have a look at the rings. So that's Uranus. So we're going to have a bit of a zoom back out. Push the time forward a little bit to make it a bit darker, and we can see there's Mars there as well, and we've got the moon up here. So this is the 21st of January. Let's have a look at what the best time would be to see that one. We'll turn off the constellations for the time being. We don't need those right now. All right, so it's getting nice and dark now. Just going to center on the moon. And so you can see here, just to the northwest, at 2200 hours or 10 o'clock at night, you can see we've got the moon and Uranus and Mars in a nice straight line, pretty much directly over northwest. All right, so we're going to move on a little bit now as well. I'm going to stop centering on the moon. We're going to skip ahead to the first week of January. Now, this one has Venus is hanging out nice and close to Saturn in the evening. So we're still at the 23rd of January down here at the moment. So you can see there's a few different things you can do with Stellarium down here, as I pointed out before. So we can turn on the constellation lines or labels if you want to know where we are. There's a couple of grids there as well that you can use for navigating your way around the sky. You can turn on or off the ground, which I like to leave the ground on because it makes it a little bit more realistic. We can toggle on the location for various deep sky objects, so that's different galaxies and things like that, planet labels and so on. So we're still at the 27th of January here. I don't want to go too fast because it can get a little bit disorienting. We've got meteor showers toggled on as well. We don't need to look at those right now. You can have a look at what exoplanets are out there as well. And as I said before, this program is all free. So this one, you just search up Stellarium in Google or Bing or whatever search engine you use, and it'll generally be the first one that comes up, and just download whatever one suits your computer, and it'll come up, and it's free to download and very easy to use and play around with. So getting there now, we're at the 1st of February. And as you can see, if you've been watching the planets there, they've been moving around a little bit as well. There's Mars just disappeared below the horizon there as well. Just scanning through. Once it gets dark, what I might do is I might actually show you something else that we're able to see during the night. There's something called the Small Magellanic Cloud. Now these, if anyone knows what they are, leave it down in the comments below. But these small and large Magellanic Clouds are satellite galaxies that orbit around the Milky Way. So these ones we can see, here we go. So we've got the small one here and the large one here. They kind of look a little bit fuzzy. If you've got good eyes, you'll be able to see them once it gets dark as well. So if you zoom in, can't get too much detail on that one. But if we have a look here, this is a satellite galaxy that's going around the Milky Way, which is pretty cool. And if you have a look over here, there's a globular cluster called 47 Tuc or 47 Tucanae. And this one is a massive group of stars that has gathered in this sort of area, and they hang out nice and close together. And if we have a look up here, we've got the Large Magellanic Cloud. This is the bigger of the two satellite galaxies, and you can have a look at what's in there as well. There's some pretty cool stuff, including the Tarantula Nebula. So this one, astronomers are great at naming things. This one looks like a dead tarantula, hence the name Tarantula Nebula. So going to skip ahead. Again, we're on the 4th of February down here. I'm just going to move the time forward a little bit. I won't keep you from the rest of the session for too much longer. Just have a look around. How pretty is that? All right, so we are at the 6th of February now. So we're going to wait just a little bit. Nope, wrong way actually. And we're going to have a look for Venus and Saturn hanging around the sun. So around this time is a good time to have a look. Once again, it's quite close to the sun, so if you are going to have a look at this one, bear in mind that the sun can blind you if you look at it through a telescope or a pair of binoculars. Please don't do that. We like our fans to be able to see the stars as much as we can see them. So you can have a look here. We've got Venus again. We've got Jupiter there as well. And you can see, having a look at the time there, that it's about 6:45 in the evening as well. So if you have a look over towards the west of the sky, if you've got a good horizon, you should be able to see that one. That's probably about all we've got time for me tonight. I'm going to hand back over to Adam now, who's going to introduce our next presenter. Thank you guys for listening. Thank you for coming along as well. Hope you enjoyed and continue to enjoy the rest of the presentations.
Thanks, Jamie. That was really interesting. I actually had no idea that Subaru got their logo from the Seven Sisters. So it's always fascinating to hear everybody's different talks and different takes on all little bits and pieces out there in the universe. So that was fantastic. All right, I think we're going to go to one of our Mount Burnett Observatory news breaks.
The Indian Space Research Organisation released some of the first photos from their Chandrayaan-2 moon mission in December. These are the highest resolution images captured of the moon's surface from orbit, at about 25 centimeters per pixel, 4 times that of the Lunar Reconnaissance Orbiter. Only 3 images have been released so far, but more are sure to follow.
Okay, it's time for Merv now. Now, Merv's going to give us some story and background on the constellation Orion and some folklore around that now. So over to you, Merv.
Hi Cosmos fans, Mervyn here, and I'm just bringing you a little view of how others might see Orion in our summer sky. Earliest records of Orion are actually from Babylon or Mesopotamia. These people saw the true shepherd of Anu, Anu being the chief god of the heavenly realms. To Middle Eastern cultures, Orion was a giant or the great hunter. He carried a large club and a shield or sometimes a bow. Across the ocean, the Aztecs saw Orion's belt and sword as fire sticks used to light a new fire at the beginning of a new year. Meanwhile, back in Eurasia, people from Belarus could see the throne, the mowers and the rake, a rather mixed up version of pre- and post-Christian cultures. In North America, the Dakota Nation and other peoples from the Great Plains saw Orion's belt as the hand, and they saw a buffalo which stretched from Canis Majoris through Orion and up to the Pleiades. Further north in the Americas, the Inuit people could see Orion's belt as the runners, a group of hunters who saw a polar bear and climbed into the sky to get away from it. Today it's used as navigation purposes. Back in Eurasia, the Macedonian people saw Orion's belt as the plough with oxen, and above that Betelgeuse as the ploughman. Mayan culture indicates they saw a turtle in the sky believed to be Orion's belt, and below that the primordial fire, which was Orion, the great nebula in Orion. Romanian culture, like the Belarus, is also very mixed up. They saw overlapping constellations of the sickle, a little plough, the great augur, and the three saints. And coming back to the southern hemisphere, the Borong people of northwest Victoria could see two teenage boys. The Borong means starry firmament at night. The Kamilarra people of northern New South Wales see three uninitiated boys as Orion's belt, commonly the Berry, and these boys are in love with the seven women, the Maya, aka the Pleiades. Across the Tasman, the Maori people see a great catamaran or canoe that was sent south in search of their ancestors' fires. What they saw was the southern aurora. They did find Antarctica. And of course, many Australians look up and see the saucepan. The 88 constellations of today's Western sky culture was actually created by people living in the Northern Hemisphere. Hence, we, south of the equator, see a lot of things upside down, including Orion. There are many stories about the constellations of the night sky. One Greek tale is about Orion and how the people of Earth were complaining to their gods that some animals were killing the people. The gods asked Orion to go and kill these animals, but Orion decided he was going to kill all the animals on the Earth. The gods, of course, didn't want this, so they asked the great scorpion to go and kill Orion. The two of them were placed in the sky, Orion chasing the scorpion and the scorpion chasing Orion. So as one rises, the other one is setting in the night sky, and the two will never meet again. And that's it, folks, for my alternative views on Orion. I hope you've enjoyed it, and if you want to get more, well, by all means look into Stellarium, where most of these images come from. My thanks to Stellarium, and you can find out more about the folklore there.
That was fantastic. Always really interesting, Merv, to hear the different takes on the constellations and the different cultures, especially depending on where we are positioned on the Earth. It's always fascinating. Sometimes you're looking at Orion, but like you said, there's all sorts of different stories around it. So it was really interesting. Fantastic. Up next, we've got Drew. Where are you, Drew? Drew's going to be giving us a run through of some more constellations and their meanings. Take it away, Drew.
Okay, thanks, Adam. Tonight I'm going to be talking about constellations and asterisms. Some of you are asking what asterisms are, and some of you are asking what's the difference. Well, I'm going to guide you through it. A constellation is an officially recognised group of stars by the International Astronomy Union, or the IAU, who are the people who killed Pluto as a planet, forming a shape in the sky bounding an area of sky. And our constellations originate from the ancient Greeks. Different cultures had different patterns that they saw in the stars, and the ancient Greeks are the ones that we've adopted as the standard. Later on, I'll mention a couple of variations, but for now, we'll stick with the standards. The IAU has since 1922 recognised 88 official constellations, 48 original Greek ones, and 40 new ones that we've added since. Here's all the constellations. I'm not going to go into them all or quiz you on them, but I will show you a few of them in picture. This is the largest constellation. It's called Hydra. It's remarkable for being the largest constellation. It's unremarkable for anything else. It's just lines through a whole bunch of stars. None of the stars are particularly significant in any way. So at least it's got some claim to fame by being the largest one. On the other hand, the smallest one, Crux, or the Southern Cross, is quite significant to us, especially in Australia. The 5 stars of the Southern Cross, being the 4 big ones and the smaller Epsilon Crucis, are all found on the Australian flag. And the New Zealanders, who are a little bit smaller, can only fit the main 4 stars in their flag. I'll come back to the Southern Cross a bit later. Merv and others have mentioned Orion the Hunter, which is one of the original Greek constellations, and he hunts various things across the sky. From Greece in the northern hemisphere looking south, they see this picture with this fearsome hunter. However, we're looking north from the southern hemisphere, so we see something slightly different. Yes, we see an upside down hunter, but otherwise we see the same thing as they see. I'll come back to Orion again a little bit later. Now, I mentioned asterisms. Aster means star. So asterisms are star things. Asterisms are groups of stars in the sky, just like constellations, but they're not officially recognised. And whilst the constellations are used to divide the sky into different groups, the asterisms don't really form any such thing. Sometimes an asterism is part of a constellation, and I'll show you a few examples of that. But sometimes asterisms cross constellations, and you've got stars from one constellation and stars from another. This is the Pleiades, as has been mentioned already tonight. Now, Merv managed to show you a whole bunch of different things that people see when they look at the stars of Orion, but the Pleiades are a bit remarkable in that all sorts of different cultures that had no contact with each other whatsoever have seen similar things, primarily 7 maidens or 7 sisters or 7 women of some kind. It's actually remarkable how many different people, completely different to each other, looked at the same period of the sky and saw the same thing. Now, all the constellations and many of the asterisms are just people linking up stars that look similar to each other in place in the sky. But the Pleiades is an example of a star cluster. So these stars are actually physically grouped together in the sky. As I mentioned, we define things by where they are in constellations. And the Pleiades is a star cluster in the constellation of Taurus. So that helps us find these asterisms relative to the constellations they're found in. Orion the Hunter, I've mentioned it and others have mentioned it, and I'm sure you'll see Orion come up a few more times tonight. This is a picture of Orion without any lines linking him. And here he is as we see him upside down in the sky with Betelgeuse, bright red star, on Orion's shoulder, and Rigel, one of Orion's feet, at the top of picture. Now, if you didn't happen to know the formation of Orion the Hunter, you might look at this and see something different. And I believe Merv and Others have touched on this already. Here we have a saucepan. Orion is an official constellation, but the saucepan is an asterism. Here's another constellation. This time it's a northern sky constellation. It's Ursa Major, which means the big bear. There's also an Ursa Minor, which is the little bear. But a lot of people, again, who don't look at things constellation by constellation, see something different here. If I highlight those, you can see an asterism called the Big Dipper. So like all the others, you'll see the constellation of Ursa Major on sky charts. You won't see the Big Dipper because it's not a formal constellation, it's an asterism. But a lot of people know the Big Dipper. Here's the Southern Cross again. I promised I'd come back to it again. And it sits there in our southern sky. However, there is a slight problem for some people. There's actually 3 crosses in that section of the sky. The Diamond Cross down the bottom there, and the Southern Cross and the False Cross. And as the name suggests, sometimes the False Cross is mistakenly confused for the Southern Cross. You can tell the Southern Cross in a number of ways, one by Epsilon Crucis there, another by the pointers that point to it. The Southern Cross is a constellation in and of itself, but the False Cross is 4 stars, 2 of which are in the constellation of Vela, and 2 of which are in the constellation of Carina. So the False Cross and the Diamond Cross are asterisms that you won't find in official charts, whereas the Southern Cross is one of the 88 recognised constellations. And these 2 are asterisms. Now here's the constellation Sagittarius, which is quite remarkable, not only for being my birth sign, but also it's the constellation in which you would find the centre of our galaxy. And somewhere in there, I can't tell you exactly where, is a thing called Sagittarius A, which is the supermassive black hole in the centre of our galaxy that we all rotate around. Now, these stars form an archer in the constellation Pantheon, but I can't exactly tell you where that archer is because I can't quite see it myself. But what I and a lot of other amateur astronomers like myself see is something else in that period of that area of sky. If I draw some lines here, you can see a teapot, which is generally, speaking for myself, a lot easier to make out than the constellation of the Archer. Now, once again, I'm going to return to the Southern Cross. This is probably the last time tonight I will. We've got the Southern Cross on the left and the constellation of Centaurus, the centaur on the right. And if you look closely in Centaurus, you'll see the Southern Cross is sitting there surrounded by the centaur. I mentioned there's 2 ways to identify the Southern Cross away from the False Cross. One is the Epsilon Crucis star there. The other is the pointers, which you can see there pointing to the top of the Southern Cross. The Southern Cross, I'll restate, is a constellation like the centaur, but the pointers are an asterism. They're a formation that's not an official star group. Now, as I mentioned right at the start, we've adopted internationally the Greek constellations, and the IAU has built on those. There are other constellations in other cultures, and I'll show you a couple of local ones. This is another picture of Orion, but this is a Torres Strait constellation called the Canoe in that same space. Where Orion's belt is are 3 brothers, and where Orion's sword is a sawfish. The sawfish was a forbidden fish, and according to the mythology, when the 3 brothers caught it, they ate it. And a goddess was rather annoyed at this and sent them up to the sky until they learned to behave better. This is not a constellation nor an asterism. This is the Milky Way, or part of it. You can see it spreads across our sky. It's actually the galaxy we're in. However, some cultures have constellations that aren't actually made up directly of stars. And if you look closely at those black areas of darker gas in the Milky Way there, you might be able to see the emu. And I can almost guarantee after you look at this and you look at the sky, you might not be unable to see the emu. And the emu rotates around in the sky through the year. And Aboriginal cultures actually made use of that to guide them on when to do various activities. Now I'm going to end it here and I'm going to pass it on to Jackie. But first, before I go, I'll just point you at a couple of further resources. The IAU has a website where you can find maps of all the constellations, all the stars, key stars in them. And if you're interested in more about Aboriginal astronomy, go to www.aboriginalastronomy.com.au and you'll find many resources on Aboriginal astronomy, including some by members of MBO itself. So thank you.
Thanks, Drew. That was fascinating. So I guess, yeah, really interesting knowing the difference between the constellations and the asterisms. I know there were a lot of comments on that presentation. A lot of other people had no idea about the difference, so it's fantastic. We're all learning something. That's what we're here for at MBO. It's always just a constant learning experience and something we all enjoy doing together. So it's probably a great time to hit share if you're watching on Facebook or YouTube, because you never know which one of your friends or family might have an interest in astronomy that you didn't even know. And I know there's quite a few of my friends that had an interest. It wasn't until I started sharing a few pictures and streams that I found that out, and I'm being able to share that with them, and just like everybody else can. So it's fantastic. All right, up next we've got Jackie. Jackie is going to be giving us a talk on Betelgeuse. Thanks, Jackie.
Thanks, Adam. So I'm going to be talking about, as Adam said, Betelgeuse, the 10th brightest star in the sky, and it's in Orion, also one of the most famous constellations in the sky. Orion's one of the oldest constellations that we still use today. It represents a giant figure in the sky. It probably originates from around the Middle East area, and the name we use, Orion, is the Greek name that's carried on today. So it can be seen all around the world because it lies on the celestial equator. So that zero line going across the middle is the equator in the sky. So it's halfway between the north and south celestial poles. So just about everybody can see it in some form or another. And it has 7 bright stars that make up the main shape of the body. And this is thought to be significant because Ursa Major and the Pleiades also have 7 stars associated with them, and they're the other 2 very ancient constellations in the sky. So let's take a look at their names, and we have Betelgeuse here on the first on the shoulder. Betelgeuse is thought to mean the armpit of the giant. Sometimes the proper pronunciation is thought to be Betelgeuse, but we often just use Betelgeuse because that's what most people associate it with. And yeah, by the way, the movie is named after the star, not the other way around. Okay, and then we've got Bellatrix, the female warrior, on the other shoulder. Down the bottom here we have Rigel, the knee, and then we have Safe, the sword. And through the middle, we have the belt of Orion. And the 3 names here all mean belt or girdle. So we have Alnitak, where the Horsehead Nebula is, and the flame, which Andrew's going to talk about. And we have Alnilam in the middle and Mintaka. But let's come back to Betelgeuse, which I mentioned is the 10th brightest star in the sky. And it's a red giant star. If you compare Betelgeuse to Rigel, you should notice the colour difference, because Betelgeuse is a red giant and one of the largest stars in the sky, and Rigel is a nice bright white colour. So the colour difference should be quite nice. Betelgeuse is also a variable star, and this means it varies in brightness over time. And this is quite normal. Lots and lots of stars are variable stars, including our own sun. And Betelgeuse, being such a huge star, is actually nearing the end of its short life. It's only about 10 million years old. So that's really, really young. But it's the bigger you are in the star world, the faster you burn. And it's near the end of its life. And as it's doing so, it's gradually expanding and cooling down. So the red colour actually tells us that it's quite cool on the surface. At some point in the not too distant future, it's going to finish the last of its fuel and collapse in on itself, forming a supernova in the process. So in October 2019 and towards the end of 2019, astronomers got really excited when they noticed Betelgeuse was fading. And it wasn't just fading a little bit, because it has a bit of a wobble, as they all knew. It was doing a really big dip. And it was a really noticeable dip. It went all the way down at least a magnitude in brightness, and it was really noticeable. I wasn't able to find a picture to compare it, but we have here what's called a light curve, and this is, you can sort of see on the left a bit of a sort of a normal wobble, and then on the right we've got the big dip. So it spent about 5 months going down, and then around about February 2020 it stopped, and then it shot back up to normal brightness again. And then since then it's sort of been wobbling about at around about 80 to 90% of its what we consider normal. And we've got observations stretching back to the beginning of the 20th century. So we know what's considered sort of recent normal for Betelgeuse. And a big dip like we saw at the beginning of 2020 it's only been seen twice before in the last couple of 100 years. But we know that we're fairly certain that it's done it before. So what was happening? Because both professional and amateur astronomers got really excited. I mean, it's dimming. What's going to happen? Is it going to go supernova? No. And as you probably realise, Betelgeuse is still with us. It's still here. So nothing really happened. And it's all business as usual. But there is a pretty good theory of what happened, and because it's a well-studied star, and because it's so huge, we can almost see features on its surface, because it's only 650 light years away, which is still relatively close. So what we've got here is a simulated model of what Betelgeuse might look like close up. Now, it's puffed up some gas and dust around it, but it's also bringing up big bubbles of dust and gas as it's dying. So we can see here it's sort of big bubbles are coming up and going down. You can see the dark patches forming as it cools right off at the top of the bubble, and then the gas sinks back down. So that's kind of what they think was happening. We just one really big bubble was pointing directly to us, and we just got the dark patch and it dimmed. They know Betelgeuse didn't really change in what it was doing, because in the infrared wavelength it was still putting out plenty of heat. So Betelgeuse, business as usual, unfortunately. And we're going to have to wait a little bit longer for it to explode. So enjoy it up there in the sky and the shoulder of Orion, and enjoy its lovely red colour up there in the sky.
Great, thanks, Jackie. There's a few nervous comments, I think. They were all a little bit worried when you mentioned supernova, so it's nice to know that that Betelgeuse is going to be safe for a little bit while longer yet. Okay, so don't forget to keep those questions coming in, folks. We're going to be awarding the question of the night with a Mount Burnett Observatory planisphere during our Q&A, which will be coming up not too far off. If you're just joining us, thanks for tuning in. We've got plenty more to go. We've got Neil giving us a talk on the Great Nebula in Orion, and we've also got Andrew giving us a tour of the Horsehead and Flame nebulas coming up shortly. So we're going to throw away to a quick Mount Burnett Observatory news break.
On the 18th of February, the newest NASA mission to Mars, Perseverance, will arrive and land. Following in the tire tracks of Spirit and Opportunity, the mission seeks signs of ancient life and will collect samples of rock and soil for possible return to Earth in the future. Going along for the ride is the experimental Ingenuity robotic helicopter. It will be the first vehicle to achieve powered flight on another planet.
How cool is that? A drone on another planet just blows my mind. It's so cool. All right, thanks for that. So we've got our Director of Astrophotography, Neil, is going to be giving us a talk on M42, the Great Orion Nebula. Hi, Neil. Yep, there you go. Welcome, Neil.
Problem, isn't it? Get out, and how you going? Yes, the Orion Nebula. I'm doing a little bit of a talk about it, or a recorded talk, showing off some amazing astrophotos, because astrophotography is a very big passion of mine and a lot of people at MBO, and the Great Nebula in Orion is one of the best targets. And, well, let me show you why. Summer is a very special time for many stargazers, as it brings with it the return of Orion the Hunter. If you've been to a stargazing event in summer, chances are good that one of the first things shown to you through a telescope is the Great Orion Nebula. It is a bright, interesting nebula that looks good in any instrument, from a pair of binoculars to a large telescope. This is why it is also a perennial favourite of astrophotographers. No matter what kind of photographic equipment you have, you can get a photo of the Orion Nebula. Even modern smartphones will show it. But when you get in closer, all kinds of interesting and beautiful details reveal themselves. Within, you will find examples of emission, reflection, and dark nebulae. This gives us a beautiful palette of colours with which to paint an image. The bright core and exceedingly faint extremities provide a challenge and interesting contrasts. And as you can see from these photos, every astrophotographer can interpret the nebula in their own way, each one being a beautiful result. Because it is so bright, you can get a good image of the Orion Nebula whatever camera you use. It looks good in digital SLRs, in astrophotography cameras that preserve the hydrogen alpha light, and with mono cameras shooting through colour and narrowband filters. Whatever your skill, there's a beautiful shot waiting to be taken. Even for experienced astrophotographers, the challenge of revealing the vast faint clouds of hydrogen within which the nebula is wrapped is a rewarding pursuit. And of course, when the professionals turn their incredible instruments to this jewel of the summer sky, they reveal breathtaking details that teach us about the formation of stars. So, next clear night, grab a camera and a tripod and point it to the saucepan. With a little knowledge of photography and some patience, there in the handle, you will see the little fluff that is the Orion Nebula. Who knows? In a few years' time, you may be hanging a print of your latest photo of it on your wall. How about that? Isn't it just the most spectacular object? I return to it every year and get a photograph, and I find it a great way to keep track of how my skills as an astrophotographer develop over time, because it's the same target and I can see how things look each time I do it again. And all the photos in that slideshow that you just saw, except one by the Hubble telescope by NASA, they were all taken by MBO members. We've got quite a few members who are very keen on astrophotography, and of course the Orion Nebula is only one of the things we love to shoot. So it's a great place to learn about astrophotography if that's something that appeals to you. I'm also going to be doing a very introductory speech on how to do astrophotography coming up in the March live stream. So if that's something you'd like to learn a little bit about and how to get started, then make sure you put that in your calendars the second Friday of March, and I'll be giving you an introduction then. Thank you.
Thanks, Neil. That's fantastic. It's great to see so many members being involved and participating and providing content for us to show to all of you. So thank you to all those members that provided their time and expertise on taking those shots. Just also, Neil does all of our little MBO Space News adverts. It's a very time-consuming process, and we thank him very much for it. They've really spucked up our stream, and we're really enjoying them, and we're going to go to another one of those right now.
After headline-grabbing news in September that phosphine, a possible indicator of life, was found in the atmosphere of Venus, the original researchers have refined their work and are now less optimistic about their original conclusions. While a setback for alien microbe hunters, this scrutiny and revision shows science at work and will help scientists when looking for such signs in planets beyond the solar system.
Always fascinating to see what's going on in the space news. Also, yes, John, the opposite of fake news. We like that. Let's go on to our next presenter for the evening, Andrew. Where are you, Andrew? What have you got for us tonight?
Hi there, Adam. We're going to have a look at a couple more nebulae, or nebulae, depending how you want to pronounce it. Okay. Let's have a look at my screen. Now, hopefully you'll have up on your screen now my Redshift program. It's not free like Stellarium, but I think it's well worth the money if you want to have a little bit closer look and some more up-to-date images of some of the features in our sky. So thanks to Redshift for allowing us to use their software. Yeah, hopefully everything's all right. Now, here we are looking east, but if we move around, let's see, I'll move back a little. Oh, there we are. Right in the middle, you should be able to see Orion. Now, it's upside down. Perhaps you can see with this, here's the sword raised in the air and a shield or something. You probably use your imagination better there. He's upside down for us in the southern hemisphere. If we just zoom in a little, you'll notice that there's a red glow around the main bright middle stars of the constellation. All through this, there are nebulae. This is the biggest one. It's almost like a bubble around the star system. I better get back to the script. We're looking here at about 1,300 to 1,500 light years away, and there are three different types of nebulae that Neil mentioned as well. The first is emission nebulae. There's one there. The second is dark nebulae, which we'll look at shortly in the Horsehead Nebula. And the third type is reflection nebulae, which are lit up by stars usually within the system. Now, Barnard's Loop is an emission nebula, and you can see it there, as I said before, like a bubble around the whole thing. It was probably caused by a star that went supernova about 2 million years ago. You probably have a better view of it in this one. And you can see it actually is, it's almost like a complete sphere surrounding the constellation. Photons of, or UV light in particular, from these very bright stars within Orion, they strip away, the power of the UV is so powerful, they strip away electrons from hydrogen atoms in this cloud. And then when the electron falls back in to the ion and they recombine, it gives off a red light for hydrogen. And this would be at least 500 years away, light years, away, and it's at least 100 light years across. Now let's zoom in a bit. There we go. And down here we've got the Flame Nebula. Just center it for you. And let's zoom in closer. There's the Flame Nebula. The Flame Nebula is an emission nebula, but it's partly obscured by dust clouds. That's the black areas here. And it's quite close to the blue supergiant Alnitak. Let's just go back a bit and you can see what I mean. Here we are. It's one of the three bright stars at the bottom of the saucepan, as we call it. There's Alnitak. You see it's very close to the Flame Nebula, and that's even taking into account parallax. It's actually quite close. So it gets its UV power from there. Because that star's close and emitting very powerful UV light, we have not just red light in this one, but also we have, because it takes more energy, other elements like helium, oxygen and nitrogen are also ionized, and this produces other colours. And hopefully now you can see another picture of the Flame Nebula which shows that more distinctly. All the different colours that you see there are caused by ionization and deionization of some of those other elements within that cloud. There are also dense regions where there are relatively young stars, and new stars are being born. And most of these new stars are also forming planetary systems. So, and here's a picture that perhaps shows that a little bit more clearly. Concentrated light areas where new stars are forming. And because they're actually spinning, they form a disk, and the accretion disk settles down after millions of years and you form planets. Now let's zoom back again and we'll come and have a look at, hang on, what's this thing called? The Horsehead Nebula. All right, let's center that. Zoom in again. Now, why on earth would they call it the Horsehead Nebula? I guess maybe because it looks like a horse's head. Other pictures, though, it looks a bit different, which we'll show you shortly. This one is a dark nebula. It's a cloud of gas and dust silhouetted against IC 434, which is a bright emission nebula. And because this is closer to us, we see it silhouetted there. IC 434 is reminiscent, I'll just zoom back a bit. You can see it's almost like hanging curtains again. You probably recognise that it's very similar to auroras here on the Earth. And it's the result of a very similar interaction between stellar winds from the nearby Alnitak and magnetic fields in this area here. So we get that same sort of aurora effect. Now, here's another picture of the Horsehead Nebula. Hopefully you're seeing it now. And here we can see stars behind the cloud shining through the dust. And although the Horsehead is very dark, invisible light, we can have a look at it in infrared frequencies and you get a much different picture. And hopefully you can see that now. This time we've got a much brighter area because of the amount of heat that is given off, radiated heat or infrared light from the Horsehead Nebula, and especially up the top. Particularly at the top, you can see new stars about to form because that extreme brightness shows you that the temperatures are reaching levels high enough to start nuclear fusion, where hydrogen will turn into helium. just like it's happening in our own sun. So young stars being formed in that area above the top of the Horsehead Nebula. Now let's get back to redshift again, and we'll have a look at NGC 1999. Let's go back a bit. It's up here with, hang on. Let's go to it. Yeah. NGC 99 is at the end of the handle of the saucepan. You probably would see it through some telescopes. Let's zoom in and we'll see what's so special about NG 1999. Look at that. Almost looks like a gibbon's face, doesn't it? And it's a reflection nebula. It's actually reflecting light from the star within it, this one here. And it's and we get a much better view of it. Sorry, I'm looking at the wrong thing. It's a reflection nebula. Oh my goodness, sorry, I've lost I lost my place. Heavens, this is all because of live viewing. Anyway, NGC is another reflection nebula with a mysterious hole. And initially it was thought to be gas and dust, just like the Horsehead Nebula. But more recently, it's been confirmed that there is nothing in the hole. Right? We're looking through it to space beyond. No explanation has yet been found for this phenomenon. We haven't observed it in any other nebulae, but here we are. We can see through a nebula hundreds of light years away. Here's a wider view, and you can see in this view the nebula itself right at the centre, but it's surrounded by a lot of reddish light, which of course would be a result of emission nebula giving off the red light due to hydrogen. Okay, now let's go back to, and let's have a look at Rigel. Rigel is that very, very bright white star up in the top left-hand corner of Orion. And if we now zoom in on Rigel, we can see nearby, excuse that, that's just my mail. We can see the Witch Head Nebula, IC 2118. Now, you'll have to ask more gifted people than me how they come up with these initials and numbers. Perhaps later on Jackie can answer a question about that. Now, this is a reflection nebula, and here's a picture of it. And in this nebula, we can see the effects of Rigel's powerful stellar winds. Rigel is a blue supergiant, at least 100,000 times brighter than our sun, and 20 times as massive as our sun, and more than 70 times wider. It's actually more than one star, probably 4 or more. And the huge amount of stellar wind that comes from Rigel is pushing material away from more dense points in the Witch Head Nebula, and we get to see that view there. I'm going to zoom back now, and there it is. So you can see there are quite a few nebulae associated with Orion, which makes it excellent viewing during summer. However, to see these nebulae, I'm sorry, the downside is you need very dark skies, no moon, you need very clear skies, and preferably a quite powerful telescope. The Great Nebula in the Orion Nebula, no problem at all. You can see that one, but it is difficult to see the Horsehead. You can see the Flame Nebula, but you'll need a really good telescope. However, if you're an astrophotographer, you can benefit from that. So as you saw from Neil, with a little bit of patient technique, and you can get some spectacular shots. So I hope you enjoyed seeing some of the nebulae in Orion.
Thanks, Andrew. That was fascinating. I know there's so much nebulosity and different objects in that section of the sky that astrophotographers love to capture. So it's fascinating to see them up close through redshift. And I know everybody watching at home was commenting while you were doing that and sharing the love. So thanks very much. Really appreciate it. We've also had a message come in from Catherine. Her son, Nathaniel, tuning in from Tassie, 6 years old, and he's in his PJs, and he's hoping to maybe come across to Vic and visit the observatory. We'd love to have you out here when it's safe too. So thank you for sharing your photos and pictures and comments. We all really appreciate it. Okay, we've got a few more bits and pieces for you tonight before we get into our Q&A. This is probably your last chance to get those questions in on social media, wherever you're watching from, whether it's YouTube or Facebook. Your last chance to get in and win that MBO Planisphere. But before that, we've got a couple of little announcements for you.
Hi folks, I hope you're enjoying this evening's stream. Coming up next, we've got your questions and answers, but before that, here are a few important messages. This series is made possible by a grant from Cardinia Shire Council. Thank you to the Council for that. This event is being held in partnership with KC Cardinia Libraries. The libraries are open again and are looking forward to seeing everyone. Don't forget, they are free and everyone is welcome. If you like what you see here and you'd like to see more, you can follow us on our social media accounts. You can see the addresses on your screen now, including Facebook, Instagram, and our website. If you love astronomy and think you'd enjoy being part of our community, you might want to consider becoming a member. Memberships are $50 per person and cheaper for families, and you can sign up on our website mbo.org.au. Don't forget, this is a monthly series, so if you'd like to be notified when the next stream is going live, then follow us on our Facebook, Mount Burnett Observatory Incorporated, and you'll get notifications when we create new events. And finally, I'd like to thank our incredible outreach team who've put together this series. Now, let's hear your questions and get some answers.
All right, so it's that time of the evening. We've got the Q&A. Hi, Neil. Jamie, how are you? Thanks for joining us. Stuart. And we've got a few others joining in. Here's Jackie. Andrew.
Hi.
And True. Merv around somewhere. Come back, Merv. There you are. Hi, Merv. Fantastic. All right, so it's that time of the evening. We've got plenty of questions, so we'll get stuck into it. I think our first one is for you, Merv. We've had a question from Michael Williams, and it's why are the pyramids lined up with the Orion constellation? And if you could take yourself off mute, Merv, so we can hear your words of wisdom, that'd be great. Thanks, mate.
Okay, yeah, something I've seen a little bit on TV. I've done a little bit of research, but yes, the three stars in the belt of Orion do roughly at the minute line up with the pyramids. One of the stars is slightly off to the left. Research shows that going back to 10,500 years BCE, the stars actually lined up perfectly with the pyramids as they are now. So the Egyptians, when they built the pyramids about 3000 BC, 5,000 years ago, how they got the alignment right, no one is quite sure. We know that the Egyptians, they didn't have watches and clocks and the equipment that we have today, telescopes, etc. They sat in the ground and observed the sky at night. And one of the things they did was looking at the sky and the constellations that they saw, or the asterisms as we might call it, but they used the stars to tell them when things were going to happen. For instance, when the sun sets and Sirius is rising, they knew that the floods were about to start. And they knew it would take about 3 months for the floods to get to full height. Now, if you know your star system, Orion and the three stars in the belt arise just before Sirius. So how the Egyptians managed to align their pyramids, yeah, it's a pretty good question. No one is 100% certain on how they did it. We also believe that the shaft into the chamber also aligned with the pole star. So there's another little one maybe you didn't know. Anyway, a bit more research, go for it. And you can actually, using stellarium, wind the date back to a period before BC, like say 5,000 years ago, and have a look at the star alignment then. And you'll see it is just slightly different, and lots of other stars are not where they are today.
That's fascinating. Thanks, Bev. Great question too. We've got one. I think this might be for you, Jackie. It's from Lois Mevis. I hope I've pronounced that right. And it's, what is the background of the zodiacs, as in how they're related to the zodiac signs? And if you could take yourself off mute, Jackie, so we could hear you, that'd be awesome.
Because everyone was frowning away at something. It's a rather ancient system where the sky around the sort of the equator's divided into 12. So it actually works out. We've currently have the sky divided into 24 hours. So we take each sign is basically assigned to 2 hours, and the beginning point is from the March equinox. So that's why it starts on March 21st. So and so the original names that we have date back to where the stars were at that time. Now, the zodiac wasn't created all at once, believe it or not. It was created in 3 parts. So there was one set of 4, and then based around the 2 equinoxes and 2 solstices, and then they had to wait 2,000 years for the next shift, and then they had another set, and then they had the last set. So it's well known that the stars in Libra used to be part of Scorpius. So so the stars there's Zubin el-Janubi, which is the best star name in the sky. Means one of the claws of the scorpion.
Can you just say that name again, Jackie? It sounds so good.
I have practiced it. Zubin el-Janubi.
I've heard it as
it's even better than Beetlejuice. Yeah. So that's why the zodiac sort of looks a bit out of whack. It starts at the March equinox, and it's assigned to each to 2 hours each. So it's kind of fixed in that way. So even though, because the Earth wobbles on its axis a bit like a spinning top, that's what we call precession, and so the actual stars themselves that symbolize the zodiac signs have shifted in the way we see them. With the ways that the astrology works, they're still working to those fixed houses. So we can still see those zodiac constellations in the sky and point them out to you. They still exist. They're not going to go away, but they just don't match up with the astrologers' star signs as they use them. So it's actually 2 different systems, and there's a lot more history to the constellations themselves and the areas that are assigned to the constellations, which only became somebody talked about the International Astronomical Union Jury. They were finalized in 1930, 90 years ago. Okay, so it was not that long ago. A bunch of astronomers got together and they said, we want to finalise the areas that belong to the 88 constellations in the sky so we can all talk the same language. And they only finalised it in 1930. So it wasn't that long ago. So there's it's really an hours-long talk to talk about the history of the constellations and how the zodiac fits into it. So that is a really, really quick summary. And I'd better leave it there.
That's great. Thanks, Jackie. I guess the person that asked that question will just have to join up as a member and come up and hear you talk about it when you do it.
And I'll watch them all night. Yeah.
Fantastic. All right. Our next question is for Stu. Where are you, Stu? It's from 8-year-old Mika. Does our galaxy, the Milky Way, have a supermassive black hole? And do we know how many there are in it? Well, maybe in our universe?
Yeah. So black holes are real fun. So yes, our galaxy does have a supermassive black hole, or has one at the very center. It's I've forgotten the actual number, a few million times the mass of our sun. So it's a really, really dense and big object. But it's actually one of the smallest ones that we found when it comes to supermassive black holes, because supermassive black holes are huge. So the distribution of supermassive black holes is, we believe that there's one at the center of every galaxy out there. That's the belief right now, though we haven't found one with everyone. So every galaxy, there's probably a supermassive black hole. There may be two. We found some where we think we found two supermassive black holes that are kind of orbiting around each other. And they can create very chaotic situations. So then your question kind of becomes, how many galaxies are there? Well, yeah, you just need to zoom in with a powerful telescope and they pop up everywhere. I don't know the exact number, but we've recorded at least a few million galaxies out there. There's likely to be 1 trillion or so in the entire universe because it's a huge place. And there's likely to be a supermassive black hole in every one of them. And there's even more smaller black holes dotted around everywhere. There's likely to be 1 billion or so in our own galaxy, or something around that. I have to look it up, but none of them are to be worried over, because they're all flying out there in space doing their own thing. It's highly unlikely they're going to bother us in our solar system anytime soon in the next few billion to trillion years. But yeah, I hope it answers everything.
That's good to know. I feel much safer hearing that coming from our resident black hole expert. Thanks, Stu. All right, our next question is for Neil. This one comes from Matt Jones on Facebook. Matt asks his understanding of that Australia wasn't good for visual astronomy due to the low attitude and turbulent atmosphere. How does MBO deal with all that in our sky? And are we using an adaptive optics sort of setup? Or is the turbulence still a problem for us?
Well, it's not actually true that Australia has any more turbulence than anywhere else in the world. Turbulence is just the movement of air, and the way the air moves works the same the whole world over. There are obviously some places that have more turbulent air, but that's more to do with the geology and the geography of the land in the area. As for what we do to deal with turbulent air, we don't use adaptive optics on our equipment. That's really something that's more designed for much bigger telescopes, much more powerful observatories. But when we're doing astrophotography, we use something called guiding, and that can help us compensate for the differences in the thickness of the atmosphere as the stars rise and set through the atmosphere, but not really keep track of the movement of the stars because of that turbulence. We call the effect of turbulence on how clear the stars are seeing. And seeing happens very, very quickly. It's what we see as twinkling of the stars. So adaptive optics is able to keep up with that very, very quickly, but that's really outside of the range of amateurs and a small observatory like MBO. However, we do have great skies up at MBO. We're away from the city a bit, so we get less light pollution. We also suffer less from the urban heat island effect, where the air in the nearby vicinity of a city is warmer because of all the energy that's being absorbed by asphalt and buildings and such, and then re-radiated at night. So we would have slightly less turbulent air than in the suburbs and the centre of Melbourne. But nothing specific about MBO or Australia that makes it worse or better. We just get along and do the best we can and hope that the weather, just not just clouds and rain, but also the seeing, allows us to get the best photos that we can.
Awesome, thanks, Neil. And I think you'll probably be going into all that sort of detail, nitty-gritty, probably a little bit in your astrophotography talk in March. So we're looking forward to that too.
Well, astrophotography is such a big topic. I probably won't be able to go into the nitty-gritty on that because our talks are 10 minutes long at most. So it'll be a 10-minute introduction. And if you want to know more about that sort of stuff, then become a member, and you'll definitely see some member talks along those topics in the future. That's
it. Fantastic. And while I've got you there quickly, this is one that you'll be able to answer nice and easily. Robert on Facebook asks, can you add your own horizon to Stellarium?
Yes, you can. And it's actually very useful to do. The hardest part about it is that you need to capture an image to be that horizon. If you have a 360-degree camera, then you can do that with a single shot. You could also do it by taking multiple photos and stitching them together to make a 360-degree photo. That's best done with a digital SLR, but it's also possible with a smartphone. You'll then have to remove the sky from the photo. You need to edit it in some editing software to make the sky transparent, and then you can load that into Stellarium. And I can actually show you, I have my own Stellarium window. I'll just load that up. And that shows you where I've put in my own virtual horizon. So I have a telescope set up in my backyard, or I set it up in my backyard. It's not permanent. And so it's helpful for me to see where the stars are relative to the horizon from the position of that telescope. So you can see this horizon around here, this artificial horizon, is a photo of where my telescope sits. So you can see the roof of my house here. And I can see here that at the moment, Aldebaran is just disappearing behind that view of the house. So when I'm controlling my telescope, this is very handy for me to know what parts of the sky I can see, what parts are going to be setting soon, and what parts are rising. So if you can get yourself a 360 photo of your own local horizon, then adding it into Stellarium is very useful.
Fantastic. Thanks, Neil. Our next question for Andrew, it comes from Lois on Facebook. Is it true that the Small Magellanic Cloud orbit the Milky Way once every 1,500 million years?
Yes, it probably is. Actually, I chose this question because the Milky Way itself is also spinning. And many of you will know that we're about 2/3 of the way out to one edge. And we're actually spinning in the Milky Way faster than we're spinning around the sun, and faster than any other types of motion. We're really moving very quickly. The Magellanic Clouds, yes, that probably do. Jackie could back me up here. It probably does take 1,500 million years to go once around us. But what's interesting is around about that long ago, we were around the other side of the Milky Way in space. So since the dinosaurs would have existed back then, and since that time, we've completed half an orbit around the Milky Way galaxy. So I don't know whether that answers the question exactly, but again, Jackie, you could probably confirm about the Magellanic Cloud.
Yeah, I think the question was 1,500 million years, and that's actually quite a long time, considering that the galaxy rotates once every 250 million years. So I'm not actually sure, and I actually haven't seen the figure for the orbit of the Magellanic Cloud, so I can't actually be sure. That's homework for me this weekend.
Yes, that's your assignment.
That's an interesting one. I haven't thought about that one before.
That's okay. We like these challenging questions, don't we?
Yeah.
Yeah, and that's something we quite often sometimes do follow-up Q&A little short videos. So that might be something we'll pop in the back pocket to have a look into a little bit more later on. Thanks, guys.
That's also one of the tenets of science is if you don't know something, you say, I don't know, and you go and research it. You don't make something up.
True. So true. And it's fascinating. There is a lot that astronomers, professional and amateur, don't know. So it's always fascinating.
Yep.
Next question for Drew. Drew, this one comes from Brett on Facebook. Why did the IAU reclassify Pluto?
Okay, this is a question that comes up quite often. There's a fairly simple definition of a planet that's divided into 3 parts. The first part is it has to be orbiting the sun. Now, Pluto is orbiting the sun, so it satisfies that requirement. The second one, it has to be basically big enough to become round. And again, Pluto satisfies that requirement. The third one, though, is it has to completely clear out its orbit. And whilst the 8 planets have done that, Pluto is not actually capable of properly clearing out that orbit. So on only one of the 3 it fails, but one of the 3 is enough, so it doesn't qualify as a planet. But it is a dwarf planet, like Ceres and Makemake and a bunch of others, and it's actually also classified as a Kuiper belt object because it actually comes from there and sweeps in past the orbit of Neptune and back out. So it's not a planet because it fails one of those 3 basic criteria.
Thanks, Drew. I know a lot of people were very disappointed when they announced that, so it's good to know the reasoning behind it.
Yeah, just blame Neil deGrasse Tyson.
Yes. Okay, our next comment, I should say question, is from Kat, and it's for Jamie. I know you've been hiding up there quietly thinking you could get away with it, but this one's for you, Jamie. What constellations can be used to help navigation?
Oh, great question. So just to make it a little bit easier, I'm just going to pull up Stellarium again. Trusty Stellarium, you can use it for so much. So if we just give it a little bit of a look, once my computer decides to cooperate with me, just bear with me. Apologies for the technical difficulties. So if we have a look here, we can see Crux. So if we use the long axis of Crux, or the Southern Cross, and we times that by about 4 to 4.5, we go 1, 2, 3, roughly about 4. That puts us right about here. And then if you drop straight down, you can see it lines us up nice and beautifully with the cardinal point south. Now, if you know where south is, you can work out where north is from that. Just do a 180 turn in the opposite direction and off you go. And that can be really, really useful, provided, of course, you have access to a clear sky and a rough idea of how long that is. If you can, put your hand up against it, kind of like that or like that, and just line it up and go, okay, the long axis of the cross is equivalent to this, so then go across the sky kind of like that. So let me just give you a little bit more of a detailed explanation. Wrong one. It's that one here. So this point here, this is the south celestial pole, and as you can see there, you drop straight down there and that goes there. So you go 4 or 4.5 lengths of the long axis of the Southern Cross, gets you to the south celestial pole there, drop straight down, and you can find south, and then you use that to navigate. If you get lost, don't quote me. Just preferably don't get lost.
Google Maps is always helpful.
Oh, absolutely. But if you've got no other choice, go for the Southern Cross. And just remember that.
That's great to know. Thanks, Jamie. Okay, we've got another one for you, Neil. This one comes from Sam Rawson, and the question is: if we are in the middle of the Milky Way galaxy, why does it not fill the sky instead of just being a band across the sky?
That's a good question, and please excuse the cat tail. But we are actually not in the middle of the Milky Way galaxy. We're actually about halfway out to the edge of the disk. So if you can imagine the Milky Way galaxy as being like a fried egg. You've got the bulge in the center of the yolk, the yellow stuff. That's where a lot of the older, yellower stars are. And then you've got a big flat area around it, the white of the egg, which is sort of the arms of the galaxy. And we're located out there. Because the Milky Way is flat, we are in that plane. And so when we look towards the core of the Milky Way, we can see it, the bulge through all the other stars. But if you were to actually look at the Milky Way from outside our perspective, well, let me show you. I can actually do that. I'll share my screen and I'll show you a fantastic application called Space Engine. And I've been using this to generate a lot of the scenery that you've been seeing in the pre-rolls and other things like that. So here we have the Earth in its position relative to the Milky Way galaxy. And you can see behind there, we've got this big bulge, and that is where the center of the Milky Way galaxy is. But with this software, we can take our perspective and we can move it away from the plane of the Milky Way. And it takes a while to accelerate to the right speed to get out there. But you can see the foreground stars moving down a bit. If we keep accelerating, here we go. We're starting to leave the plane of the Milky Way. And you can see now that as we climb above it, we pass through all these clouds and gas and dust and such. And now we have a much cleaner view back to the center of the galaxy. If we keep going up and change our view, we are now more over the Milky Way galaxy. So if our perspective was from outside the galaxy and looking back at it, then it would probably fill up a lot more of our sky. It would take up maybe a quarter or a half of our sky, depending on how far away we were. But because we're inside that thin plane of the galaxy, then it actually looks flat on, edge on. And that's why we see it as a band across the sky. We're inside this flat disk. The stars we see all around us are nearby stars, but they're concentrated more thickly along that flat disk. And so we see the band, which is just more stars, along that plane of the Milky Way galaxy.
Thanks, Neil. That was a great question. Okay, so we've got a few questions for Jackie. I'll pop these all together for you because they're all sort of I think they're related. One's from Warren, and it's asking about Betelgeuse and the dust cloud. Does the dust fade? Susan's asking about nebulas and can they disappear? And Lee is asking about is there much change in nebulas over time? Wonder if they shift a lot.
Yes, they do. And there's quite a few good pictures around to show nebulas changing. Some don't change much. So, like if you photograph the Orion Nebula, you won't see much there. But some, like the Crab Nebula, which is a supernova remnant, that has seen some changes in it. And there's another very well-known star in the constellation Monoceros the Unicorn, which is another variable star, which had a big outburst. It's probably about 20 or so years ago. And now Hubble's been keeping an eye on it. It goes back every year or so and photographs it. And they've got a beautiful sequence of it throwing off this huge thick shell of this white and brown dust that was part of the event. There's also things like around in the Eta Carina Nebula, where the star Eta Carina itself, around about 1850, it had a huge outburst. So there's been a lot of changes there. And in the background, there's a darkish nebula called the Keyhole Nebula. Now, people used to, before there was photographs or photographs were common, they actually drew a lot of pictures of that area because it was studied. It was a big thing. That the explosion, the outburst of this star, it became the second brightest star in the sky in the mid-19th century. So they were drawing this area all the time on a regular basis. Particularly here in Melbourne, the Melbourne Observatory would have been looking at it all the time. And so there's these beautiful hand-drawn pictures of it, of the Keyhole Nebula. And you can compare the pictures now. So you can take a picture of the Keyhole Nebula in that area around Eta Carina and compare it to the old hand-drawn pictures. And you can see definite change in that area. So yes, the nebulas do change. And what's happening is Sometimes we don't know what's happening, but sometimes we know, like in a situation like the Orion Nebula, where the new stars are being born, they're putting out enormous solar wind. I mean, we have just like it's almost just a breeze blowing out of our sun. But where the new stars are being born in places like the Orion Nebula, it's a huge gale, and they are blowing enormous winds and dust away from new stars that are being born. And some of you out there probably know the Pillars of Creation picture from the Hubble telescope that was famous for a while. They are being battered by a hurricane of stellar winds from some stars which you can't see above them inside the Eagle Nebula, where another new cluster is being born. So things are nebulas are being worn away and changing all the time. Some of them we can see changes in, and we can see them changing in our lifetime. Others we won't see change in our lifetime. And planetary nebulas only last for 10,000 years. That is a blink of an eye in stellar terms. And that's basically what our sun is going to do. That phase where small suns like ours puff out, they form a planetary nebula. That phase only lasts 10,000 years, and then they're gone. So we'll have to talk about planetary nebulas at some stage and tell you all about those fascinating things. Yeah, somebody asked about God's Eye tonight, I saw. It wasn't in our neck of the woods tonight, so that's a planetary nebula. So we'll have to talk about them because they're really pretty. Yeah, there we go.
Absolutely. Thanks for that, Jackie. That was a really great answer. Okay, our last question for the night is our winner for the question of the night, and this goes to Savvy, age 15, and it is for Jamie. Jamie, what happens if one of the stars in a constellation burns out and disappears?
Well, that is an absolutely amazing question, Savvy. I was delighted when I saw it, I'll be honest. So I'm just going to pull up Trusty Stellarium again, make it a little bit easier to understand. So we see all the stars in the constellation of Orion here. So as Jackie was talking about earlier, we've got Betelgeuse, we've got Bellatrix, Rigel up there as well. Now, I'm going to pick Rigel for my example here, just to make it nice and easy. So if Rigel were to disappear overnight, now bear in mind that stars don't disappear overnight. So hypothetically, if Rigel were to disappear in the blink of an eye, all that would happen is that there would be a blank spot there. Now, the rest of the constellation would be intact, just missing that corner there. So it would probably look a little bit different. This line here would possibly be a bit more wonky there, and we just cut out that little corner there. Now, if Rigel, or possibly more accurate idea would be to use Betelgeuse for this one. If Betelgeuse went supernova, it wouldn't ruin the whole constellation. The way that stars are arranged in the sky is completely random. They're not arranged in that pattern in the sky. They look like that from our perspective here on Earth. They're scattered throughout the galaxy, and when we look out from our vantage point here on Earth and we look out to the stars, that's how they appear to us. So if Betelgeuse was to go supernova, it would just appear as a beautiful supernova or nebula, like what you've seen tonight. And it would likely still, after a while, it would dim down and we'd be able to see it similar to a star, just the naked eye. But for the most part, the rest of the constellation would be intact because there is so much distance in between these stars. There is light years and light years and light years in between them. So if one star exploded, it wouldn't have much of an impact on the rest of the constellation at all.
Fantastic. Thanks, Jamie, for running through that, and congratulations to Savvy for the question of the night. If you reach out to MBO on Facebook Messenger, or you can catch us on our email, that's info@mbo.org.au, so we can get some details and get that planisphere out to you very shortly. I think that that will wrap us up for this evening. I'd like to firstly thank all our presenters here on our Q&A panel. They've all put in a huge amount of effort to make tonight happen. Our producer Petra, who's working behind the scenes, thank you very much for your time. And all our other volunteers that are working very hard on Facebook and YouTube and our other social media platforms to make tonight happen. Also like to thank Casey and Cardinia Libraries again, our sponsor for tonight's show. For without you, these events wouldn't be happening. That's all from us and the outreach team here at MBO. And Archie, thank you for joining us. We hope you've learnt something, and we hope to see you up at the observatory in the near future. Thank you. Good night, everyone. We'll see you next time.
Good night, everyone. Bye-bye.